Hello team, this is Chapter 9 review, so let's get started. Alright, so problem 1. The vertices of parallelogram ABCD are A, 1, 1, B, 3, 5, C, 11, 5, and D, 9, 1. Graph the image of the parallelogram after a composition of the transformations. That means it's going to be one transformation, for example the dilation, then we're going to build on that and do a reflection to whatever came out of the dilation. One builds upon the other. That's what it means when you say composition of transformations. Okay, in the order that they are listed. Okay, so the first one we're going to do is the dilation centered at the origin with a scale factor of 2. So if it has a scale factor of 2, then what you do is you take that scale factor of 2 and you multiply it by each coordinate of the first point. So 1, 1 becomes 2, 2. And similarly, 3, 5 would become 6, 10. And by the way, there should be a prime on there. And C prime then would become 22, 10, and D prime would become 18, 2. And then the next thing we're going to do is the reflection in the x-axis. And remember, a reflection in the x-axis changes only the y-coordinate. So A double prime will be 2, negative 2. B double prime will be 6, negative 10. C double prime is 22, 10. And D double prime is 18, negative 2. And then if you graph that puppy, you get parallelogram A double prime, B double prime, C double prime, D double prime is right there. Okay? And then moving along to problem 2. Use the origin as the center of the dilation and the given scale factor to find the coordinates of the vertices of the image of the polygon. Okay, so first you have to know what L is. Okay, and L is 4, 0. So you have L being 4, 0, and then let's see. Oh, the scale factor is 3. So you multiply both coordinates by 3. You get 12, and then 3 times 0, of course, is 0. So you get 12, 0. Okay? And so you have 12, 0. M, however, is 0, 3. So M is 0, 3. And you multiply both of those coordinates by 3, and you get 0, 9, right? 3 times 0 is 0. 3 times 3 will be your 9. So you would get 0, 9. And then you find the coordinates of n, multiply each one of those coordinates by 3, and you get that n prime is 6, 12. So there's your answer right there. Okay? And moving right along, the endpoints of segment CD are C, 1, 2, and D, 5, 4. Graph the image of segment CD after the glide reflection. Okay, the glide reflection, that's another way of saying that it's a composition of transformation. So one builds upon the next one. Okay, in each of the problems below. So 3, a translation of xy becomes x minus 4y, and then after that, a reflection in the y-axis. Okay, so this is the translation first. So first, we'll start off with the object, which is C is 1, 2, and we're going to do x minus 4, comma y. Right? It's a translation 4 to the left, but no up or down, right? So then you get negative 3, 2, right? Because 1 minus 4 is negative 3, and the y stays the same. All right, and then we're going to reflect that in the x-axis. And of course, the generic rule for transformation for reflection in the x-axis is xy becomes x negative y. So then you get negative 3, negative 2, right? Because you basically take this and flip around to the other side of the axis, right? So that's your C double prime. And then similarly, D is 5, 4. After the translation, you get 1, 4. And then after a reflection in the x-axis, you get 1, negative 4. So what does the new line segment look like? Right there. That should be everyone's answer. That should be your answer. C double prime, D double prime. All right, and then number 4 is a translation. And then remember, this word should be a rotation. So that should be rotation, right? I went over that in class. That's a rotation. And so that was a mistake that, we made. So our apologies here, the Geo team. But anyway, so you start off with 1, 2, and you're going to translate it 6 units to the left and 1 unit up. So 1 minus 6 is -5, and 2 plus 1 is 3. So it should be -5, 3. And then after rotation 90 degrees about the origin, that's xy becomes -yx. Okay, remember you need to memorize those rules. Rules for rotation, clockwise and counterclockwise, and the 4 rules of reflection. All right, and so you get finally C double prime is -3, -5. And then similarly with D, if you start off with 5, 4, after the translation you'll get -1, 5. And then after the rotation, 90 degrees about the origin, counterclockwise, by the way, this is counterclockwise, then you get -5, -1. And so what does that line segment look like? Voila, right there. That's your C double prime, D double prime line segments, okay? Remember what voila means. It's English for voila. So moving right along. Okay, number 5, we have graph the composite transformation of segment FG below. First we have a reflection and then a translation. So if we start off with F, which is -1, -3, and the line of reflection is in the line x equals 1. So if you graph it, you can use the counting method, right? The image F is 2 in front of the line of reflection. Therefore, you add 4 to the x value. Okay, you add 4 to the x value. So 4 plus -1 is going to be your 3. Okay, and then you're going to do a translation. So you add 2 to the x and you add 1 to the y. And then you get finally that your F double prime is 5, -2. And then you have your G. Your G is at -4, 2, but it's reflected around the line x equals 1. And so -4, 2, if you use the counting method, is going to be 5 in front of the line of reflection. So you have to add 10 to the G value, to the x value. You have to add 10 to the x value. So 10, -4 plus 10 is the same as 10 minus 4, which is 6. So it becomes 6, -2, after it's reflected in the line x equals 1. And then, after a translation, it becomes 8, -1. Okay, so those are the 2 coordinates of my final image. What does it look like? It looks like that. And so it is off the grid. It's off the grid by 1. I guess that's another mistake that the book made. But I think that's no big deal. As long as there's some learning involved, this would be the image, the graph of the image, rather. All right, number 6. Describe the compositive transformations for each of the diagrams below. And, we're going to state the coordinate rule. Remember I told you that you're not responsible for parts of each of these ones. I mentioned this about 2 times per period every day last week. I don't want you guys to be overly concerned, right? We're not going over reflections about a point where the center of rotation is not the origin, okay? All of our centers of rotation that you'll see on the test are going to be around the origin. So anyway, going from A, B, C, D to A prime, B prime, C prime, D prime, I told you, is fair game. And that one is a reflection along the line y equals 1/2. Okay, so it's along this line right here, if I can kind of draw that. Okay, that would be the line y equals 1/2. It was reflected around there. Okay, and oops, what did I do there? And sorry about that. Hold on, bear with me here. Okay, so it's a reflection along the line y equals 1/2. Okay, and then to go from the prime figure to the double prime figure, this is the part you will not be responsible for. That's why I put a strike through it. The answer, though, is a 270-degree counterclockwise rotation about the point 1, -3. Okay? Very difficult to appreciate where that comes from. In later chapters, though, I do plan to show you a technique or two on how to do that. And I think by that time you'll have an appreciation of the technique, and I think you'll really think it's kind of cool and kind of neat as to how to find a point of rotation that's not at the center. And it's kind of a fun little mathematics activity too to do that. But anyway, right now we're striking that through. You are not responsible for that, okay? That was actually an error that we geometry teachers found, but we thought we could still give it to you as an extra challenge problem. But you will not be responsible for that kind of material on the chapter test. So don't worry about any rotations that are not around the point 0, 0. Okay, all your rotation problems will be around the point 0, 0. So don't worry about it. All right, the next problem, I called it problem 7. Here, I'll fix that. There, it's problem 7 now. Okay, so that's what I meant by problem 7. And to go from the original figure to the primed figure is a 90-degree clockwise rotation about -2, 1. Again, you're not responsible for that kind of material, but I don't think that was too difficult to see, right? You have, this is the original figure, and it was just dropped, boom, 90 degrees clockwise, okay, about the point -2, -1 right there. So that was your pivot point, right? That's your center of rotation, that's your pivot point, and it was flopped over 90 degrees clockwise, okay? So again, that's not going to be on the test, but I think that's kind of a good challenge problem, okay? But look at that. We're striking it through. You're not responsible for that. And then to go from the prime figure to the double prime figure is just a translation of 5 units to the right and 2 units down, and I left that in vector form, okay? So I hope I didn't go through this too quickly for you, but we are going to go over this next week in class. It's just, again, that I took a vote of all my classes, and all the classes, a majority of you folks voted that you wanted me to post this over the weekend, that you would go and check it out over the weekend, so that's what I'm doing. But we are going to go over this in class, and if you have any questions, of course, you can feel free to contact me at your convenience. Ask me in class, out of class, we can meet, during your free periods, before school, after school, brunch, what have you. It would be my pleasure to meet with you and answer any questions you might have. And that's it for now, and have a wonderful weekend. Bye-bye. Okay, and in playing this back here, I noticed that 2 times I call this point -4, 2. So I do apologize for that. Of course, this is the point -4, -2. So, if I ever make any errors, remember, come, bring that to my attention. You might even earn some extra tickets for our lottery drawing, right? I always like to be corrected. And, again, I'm sorry for that. But anyway, the point is obviously -4, -2. I did correct myself later on, but I want to make sure, by the time I got to here, I started calling it -4, -2. But sometimes I get distracted. I'm kind of playing around with the Doceri features and trying to change colors and features. It's kind of something that I'm doing behind the scenes, and that's why sometimes I'm not looking at the screen like I should be. But anyway, I do apologize, and I hope that didn't confuse you. Like, what? He keeps calling that -4, 2, but there's a negative there. All right, so I do apologize, and to kind of make it up to you, I will tell you another geometry joke. So here's my geometry joke. Why doesn't anybody talk to circles? Why doesn't anybody talk to circles? Answer: because there's no point. All right, and I'll leave you with that. Goodbye.